Okay, we're going to solve question number 7. So what do we have here? We need to evaluate integral 4 over 2 plus 4x dx. Okay, let's do it. Integral 4 over 2 plus 4x and dx. Every time when we have their addition, subtraction, and especially related to fraction, we are going to use method of substitution. In this case, I'm going to substitute 2 plus 4x and substitute it with du is equal 2 plus 4x. Okay. Oops. 2 plus 4x. And from here, du is going to be, derivative of 2 is going to be gone, 0, and it's going to be on the derivative of 4x, it's going to be 4, and derivative of x dx. Okay, so next. So I am going to write down 1 over 2 plus 4x, and 4 I write here, dx. Why did I do that? Because for dx I'm going to replace with du, and 1 over and 2 plus 4x I'm going to replace with du. So it's going to be 1 over 1 over u, and 4 and dx, it's going to be du. Here is one of the main rules of natural logarithm. Integral 1 over x dx is equal natural log x and plus c, which means from here we are going to get this is going to be natural log absolute value of u and plus c. So replacing back u with 2 plus 4x, this is going to be equal natural log absolute value 2 plus 4x and plus c. Okay, let's go back and write down the answer. Natural log. Okay, where is absolute value? Let me see. Is that it? Yes. So it's going to be 2 plus 4x and covering absolute value. No. Where was that? Looks like here. And plus uppercase C. Okay, a good job. Moving to next question, question number 8. Two plus 1 over 2 plus 5x. And the fact that you have x is not equal to 5th, that's a domain, because if negative 2 over 5, if x is equal negative 2 fifth, denominator becomes 0, which cannot be. That's why we put that x cannot be equal negative 2 fifth. Okay, let's now evaluate this one. Let's see how much we're gonna get. And it's gonna be integral 1 over 2 plus 5x and dx. Okay, so we are going to substitute the same way, right? So it's going to be 2 plus 5x, that's going to be u, 2 plus 5x, and du is going to be, how much? Derivative of 2 is 0. It's going to be 0, and I'm going, derivative of 5x is going to be 5, and derivative of x, because we don't know how much x is. So, okay, but we need this 2 plus 5x, it's going to be substituted by u. But here we have 5 at the dx, we need 5 dx. This is what I'm going to do. I'm going to rewrite 2 plus 5x, and I'm going to squeeze here 5 dx, so I can replace with du. And because I squeezed here 5, I'm going to write out here 1 over 5. I could put in print in under radical also 1/5, but it's still going to come out anyway. So therefore, what do we get here? This is going to be du, and this is going to be u. And as a result, we are going to have 1/5 integral 1 over, let me go step by step, 1 over u and du. This is equal 1/5 natural log u plus c, which is going to be, in our case, 1/5 natural log, we substituted 2 plus 5x, right? Our u, so it's going to be 2 plus 5x and plus c. Okay, and this is going to be our answer. Let me put it back. So this is going to be 1/5 okay, natural log supposed to be, I thought it's L. No. Hold on, I cannot find letter. Oh, here, L, N, and then it's going to be absolute value 2 plus 5x, closing absolute value, and then plus c. Okay. Nice work. Moving to question number 9. What do we have? 1 plus 18x. Okay. Well, let's see how we're going to solve this one, if it's going to be the same way or not. So we have integral 1 over 1 plus 18x dx. Let me double check just in case I have hesitation. 18x, correct. All right, so just refresh your memory one more time. Integral 1 over x dx is equal natural logarithm x plus c. So let's substitute here. U is equal 1 plus 18x. Okay, and du is going to be 18, because derivative of 1 is 0, derivative of 18x is 18, and derivative of x. So we get integral 1 over u, and then here is going to be 18. I need to get 18 dx, right? Let me change the color. Actually, I don't want to right away use u. Let me arrange everything and then we'll go there. 1 plus 18x okay. Now instead of dx, I need 18 dx, so I'm squeezing here 18 dx and taking out 1 over 18, so not to disbalance, right? Because I multiplied by 18, now I have to divide by 18 also, which is 1 over 18. So from here, what do we have? This is going to be my u. This is very thick. And this is going to be du, right? So from here, we are getting 1 over 18. It's going to be 1 over u and du. And from here, we are getting 1 over 18 natural log u plus c, which is going to be equal 1 over 18 natural log u is 1 plus 18x. 1 plus 18x and plus c. Okay, so let me write down real quick. Okay, so the answer is going to be 1 over 18, and then it's going to be natural log ln. It's going to be 1 plus 18x and plus c. Okay. Nice work. All right, so now we are moving to question number 10. This is also a very similar one, not a problem at all. So let's see how we're gonna solve this one also. 5 minus 7x, okay. Integral 1 dx, 5 minus 7x. So what do we have here? U, substitute 5 minus 7x. So du is gonna be, derivative of 5 is 0, and negative 7x gonna be negative 7, right? Derivative. And derivative of x dx. So I need here negative 7. So I'm going to do the following. Negative 1 over 5 minus 7x. And here I am multiplying by negative 7 and dx. And outside I am multiplying by negative 1 over 7. So not to disbalance, negative 1, 7 times 7 negative 7, I'm going to get 1. Okay, so not to this balance. If you multiply by 7, then we have to divide by 7. And if we divide by 7, then we have to multiply by 7. Something like that. And what we're going to get, this is going to be our u, and this piece is going to be our du. So from here we are getting negative 1 over 7 integral 1 over u and du. All right, so from here the answer is going to be negative 1 over 7 natural logarithm u and plus c. So this is going to be equal negative 1 over 7 natural logarithm 5 minus 7x and plus c. So let me write down 5 minus 7x plus c, and here is negative 1 over 7. Okay, so negative 1 over 7 and then natural logarithm and absolute value 5 minus 7x 5 minus 7x absolute value and plus c. Good job. All right, so I think we learned the how to deal with integral with natural logarithm. So moving to question number 11. Okay. So this time we have definite integral, which is on interval negative 2 and 0, and 4x squared, integral 4x squared e to power x to 4 dx. Let's see how we're going to solve. We are still going to do substitution. Let me write down integral negative 2 to 0 4x cubed e to x to power 4 and dx. Okay, so what we're going to do in this case, we are going to substitute u. It's going to be substituting x to power 4 in this case. Do I have x to power? Yes, let me clean this. It looks okay. Before I move any further, okay, let me take this dx, I mean du. It's going to be so du is going to be equal 4x cubed and dx, right? Okay. So we have x cubed, 4x cubed dx. Here we have 4x cubed and dx. It's going to be our du. And x to 4, it's going to be our u. So let's write down integral negative 2 and 0 e to power, I'm going to put u, right? Because x to power 4 I replaced with u. And me see, 4x cube. Oh, it's completely disappeared. Okay, I highlight them this way. 4x cube and dx, it's gonna replace me du, right? So, and from here we have a new rule for integral. Integral e to power u du, it's equal e to power u plus c. Just like derivative of e to power u is equal e to power u, opposite. So it doesn't matter which way, integral or derivative, it's going to be the same thing. So from here, my answer is going to be e to power u, right, on interval negative to 0 and plus c. So I'm going to substitute. Again, you bring it back. It's going to be x to 4. So answer is going to be e to power x to 4 negative 2 0 plus c. So from here I'm going to get e to power, first I'm plugging the ending value, which is 0, because negative 2 is smaller than 0, right? Negative 2 is beginning, 0 is ending. So it's going to be 0 to power 4, right? Minus e to power negative 2 to power 4 and plus c. So what do we get? E to power 0, that is to power 4, it's going to be 1. Now minus e, negative 2 to power 4, we usually used to do power to power, but in the case of this case, e to power negative 2, that is to power 4, it's going to be indeed negative 2 to power 4, which is going to be positive 16, right? Negative 2 times negative 2 times negative 2. You indeed raising to power 4, and you get 16. So it's going to be e to power positive 16 and plus c. And that's going to be our answer. Let's place. So 1 minus e to power 16 and plus c. Okay. Why is it not right? Let's check what's happening here. Of course, it's a definite integral, so integral, it's giving which piece we are integrating, so we don't need c. Okay, that's it. Good job. Question number 12. How we're gonna solve this one? So I believe we are going to substitute again. Let me take a picture of it. Otherwise I can type wrong. Okay. This is gonna be integral from 7 to 8, and we have x times x squared minus 49 squared dx. All right, how we gonna solve this one in that case? So let's start solving. I'm going to substitute x squared minus 49 with u. (49), and from here my du derivative is going to be 2x, negative 49 derivative is going to be 0, and 2x dx, right? Derivative of x. Okay, so we need 2x here. We don't have under integral 2, therefore I'm going to take 1 over 2 out and write down 7 and 8, because 2 times 1 over 2, it's going to be 1, right? So therefore it's going to be x times x squared minus 49 squared, and adding here these 2, and dx. Yes, so from here we are going to have 1 over 2 integral 7, 8, and it's going to be 2x dx. That is going to be x, 2, and dx. That's going to be our du. And x squared minus 49 is going to be our u. So it's going to be u squared and du, right? Again, 2x dx. X, 2, and dx. It's going to be our du. And x squared minus 49, it's going to be our u. So we are getting u squared. Okay? So from here, just real quick, remind you, integral x to power n dx is equal x to power n plus 1 over n plus 1, right? And plus c. So we're going to take this out, and it's going to be 1/2 7 to 8, and it's going to be u cubed. Oops, I'm already taking out u cubed over 3, right? It's going to be 7 and 8 interval and plus c. So from here, actually we are not going to put c because we have interval where we are going to integrate, and this is going to be 1/2. Well, I would put 1 over 6, so 1/2 and 3, it's 1 over 6. And our u was x squared minus 49 cubed, and this is going to be between 7 and 8. So from here we are getting 1 over 6, and let's place x squared. First we take 8 squared minus 49, and this is to power 3, and minus again 1/6. It's going to be 7 squared minus 49 and cubed. Okay, so how much we're going to get? 1 over 6, 8 squared, 64 minus 49 cubed, minus 1 over 6, 7 squared, 49 minus 49. Okay, to power 3, this is going to be 0, right? 49 minus 49 is 0. We are going to have 1 over 6, 64 minus 49, 14 minus 9 is 5, 5 minus 4 is 15. So it's going to be 15 to power 3. Okay, well, let's see. I'm going to do this way, since 6 I can divide by 3 and 15 also can divide by 3. 115 I will leave here, and here I will get 15 squared because I have degree 3, so 3 times, right? 15 times 3 times 3. Okay, so from here we are getting and this is gonna be equal 15 and 6 by 3. This is 2, this is 5, and we are getting 5 over 2, 15 squared, 225. And this is gonna be equal to 25 times 5, 5 times 5, 25, 2 in mind, 10 and 2, 12, 1 in mind, 10 and 1, 11 over 2. 1125 over 2. 1125 over 2. Fantastic. Solving question number 13. What do we have? X minus 4 cubed from 0 to 4. X minus 4 cubed from 0 to 4 dx. So again, here we're going to do substitution, and that is going to be x minus 4. Accordingly, once we take derivative, du is going to be dx, right? Derivative of negative 4 is 0. So we are getting here 0 to 4. X minus 4 is u cubed, and dx is equal du, right? So from here, what we are going to get, it's going to be u to power 4 divided by 4, right? Based on our well-known formula, x to power n dx is equal x to power n plus 1 over n plus 1. And this is going to be on interval 0 and 4. Okay, let's solve it. Okay, a cube. Oh, okay. So we have 1/4. Instead of u, we are going to plug x minus 4 to power 4, right? Okay, and between 0 and 4. So we get 1/4. Instead of 4, x, I'm plugging 4. 4 minus 4 to power 4. And minus 1/4, 0 minus 4 to power 4. So in one time, I'm plugging the value of 4 and minus value of 0. What do we get? This is going to be 0 because 4 minus 4 is 0. And I'm getting negative 1/4 and negative 4 to power 4. So it's practically going to be 16 times 16 because 4 squared is 16. So 16 times 16, it's going to be 256. And I don't know if it can divide by 4. It's going to be 64. Now this number is going to be positive because we have even degree. Negative 4 times negative 4 is 16, and 16 times 16, 256 divided by 4, it's going to be 64. Okay, let's see. 64. All right. Oh, I forgotten to put negative in. I thought I was recording, and I just found this mistake, negative 64, because here we had negative 1/4. See, minus this negative here, so 64 also here. And I forgot that I'm not recording. I'll just plug 64. Trust me, it's correct. All right. And the last question is going to be number 14. Oh, we have square root. Very interesting. Let's see what it is. Okay, so 12 minus x squared. Take a guess how we gonna solve this one. What we gonna substitute? It's gonna be very interesting to solve this one. All right, let's start solving. So x times 12 minus x squared. Excuse me. X square root 12 minus x squared dx. All right. So, as you can guess, we are going to substitute with u 12 minus x squared. And from here, du is going to be derivative of 12 will be 0, and I will get negative 2x, and derivative of x dx. Okay, so what do we need? So for du, let me rewrite. It's going to be 12 minus x squared, right? And here I will have x I'm writing here, and dx, but we need negative 2. So I'm going to put here negative 2. Oh, doesn't look good. I'll do this way. Okay, multiply negative 2, which means here it's going to be negative 1 over 2. So they can cancel each other, right? Okay, and let's see what we are going to get. We are going to get negative 1/2 integral square root 12 minus x squared. It's going to be square root of u. And this piece is going to be du. Right? Now, how are we going to take a derivative? Integral. I'm going to rewrite negative 1/2 integral square root of u. I can represent as a u to power 1/2, right? This is 1, this is 2, so 1/2. 1 comes here, 2 comes to denominator. So I'm going to write down u to power 1/2 and du. So from here, it's going to be negative 1/2. And so 1/2 derivative, integral of x to power n is x, integral x to power n dx is equal x n plus 1 over n plus 1, right? So from here, 1/2 plus 1, it's going to be 3 over 2, 1.5. And we divide by 3 over 2, right? And plus c. Since we don't have definite integral, we don't have integral specifically where we are going to integrate. Therefore, we are putting there c, which is going to be antiderivative. Let's say if I had constant and was 0, now it's going to c be valid because it can be some number, a whole number under integral. Okay, so what we get from here, I'm going to replace it's going to be equal negative 1/2. Here it's going to be times 2/3. Okay, 2 and 2 gone. We are end up with 1/3. And instead of u, we have 12 minus x squared. So 12 minus x squared, and that's to power 3/2 and plus c. That's it. So it's going to be negative 1/3 and 12 minus x squared to power 3/2 and plus c. Let me take a picture so I won't forget the whole answer. There we go. And this is gonna be negative 1/3 times, we put parentheses, twelve minus x squared, closing parenthesis, okay, and plus c. Okay. Oh, here it has to be 3/2. 3/2. Now we are done. Bingo. Okay, we are done with homework chapter 4.4, 4.5. We have left one homework, and I'll release quiz and test from these homeworks. Okay, these two homeworks. Okie dokie. See you next homework.